I welcome each and every one of you to today's class again. We'll be starting from what we'll do a brief recap of what we started with last week. We started with algorithm analysis, and before then, the assignment which I gave, I've seen. So most of you have seen the assignment. Please, I want all of us to get something clear for this assignment. The algorithm which I asked us to implement is an algorithm that we actually sum up the total even number between 1 to 50. Please understand that there are different ways of writing an algorithm. Most of us, what we did was we went online to check for something similar to that. But understand that most everybody, if you call 5 or 6 programmers and give them the same problem, they can't actually solve that same problem in one way. They can't solve it in one way. Please take note of that. So it's like we don't really understand the assignment. In doing this assignment, I want to start with that because part of what we will be doing today is analyzing how an algorithm should be. When we discuss designing or designing an algorithm, so you get to understand that there are so many processes that is needed as a programmer before you design an algorithm. You have to understand the problem first of all. So for that assignment, understand that there are some variables. You have to understand what they are. You have to understand what is needed for you to implement such, or for you to develop a model for that kind of algorithm. Understand that the variables that you need to implement, and first of all, are integers, numbers which are integers. And firstly, then secondly, even numbers, and understand that even numbers are numbers that can divide itself without leaving a remainder. That means the numbers should be 2, 4, 6, 8, 10, like that. Then if you count from 1 to 50, understand that we are having 25 variables. 25 variables, which are 25 even numbers. 25 even numbers. So that is for the second one. Then thirdly, I'm bringing out the parameters which you need to understand. That is, we are tearing down the assignment. Then thirdly is for you to get the mean. So for you to get a mean of a number is you sum the whole numbers together, you sum everything together, then you divide it by the total number of counts. Sum the whole numbers together and you divide it by the total number of counts. That is, we are having 25 numbers, even numbers from 1 to 50, which are 2, 4, 6, 8, 10, 15, 2, 4, 6, 8, 10, 12, 14, 16, like that, to 50. Then all this number individually, you sum them together, then you divide them by 25. You divide them by 25. That is the third one. Then if the fourth one is for you to display the variable, display the result. So understand that all these things are the parameters that are needed for you to understand in that assignment. I saw so many of you, most of you were actually doing a different thing entirely. Some of you actually understood the problem, but you don't actually know how to implement it. So, but understand why I'm taking my time to discuss about this assignment, because we are going to be talking about how to design an algorithm. There are things which, as a programmer, which you have to understand. So that is why I took my time to explain this thing. So that is for that. We started with algorithm analysis last week. And we were talking about that the algorithm analysis is a type of is a means which you use to checkmate the efficiency of an algorithm. And there are two things, there are two different ways which that can be done, which the first one is your preporal analysis and the second one is the post-poral analysis. Your preporal analysis is talking about the theoretical analysis. The theoretical analysis, that means it's just an assumption. Take for instance, you are assuming all things being equal, everything is going to work out. All things being equal, that is just a theoretical analysis, theoretical assumption. So that is for your preporal analysis. Then for the postporal analysis, talking about the empirical analysis. Empirical analysis. That means in this situation, you have implemented the program, or the algorithm, and you are now running it. Now you are getting out the statistics, whatever that is required after the end of the operation. You are now getting out the statistics of what actually happened. That is what is called algorithm analysis. Then we went further talking to buttress more about this algorithm analysis. We talked about algorithm complexity. Algorithm complexity is telling you that the function at the measure of the time and the space used by the algorithm in terms of input. The complexity of algorithm is the function of the measure of time and space used by an algorithm in terms of input. Understand that your algorithm is actually the efficiency, or how fast or how slow or whatever it is that at the end of the day that your algorithm brings out. Understand that it's actually being ruled by the space of your hardware, and secondly by how you implemented your algorithm, which is talking about time. That these are two functions, these are two things that actually governs your algorithm. Okay, from there we went further, we talked about space factor and time factor. These are two things that still buttressing on this algorithm complexity. The space is measured by counting the maximum memory space required by your algorithm. Then your time is being measured by the counting number of the key operation. So these are the two things which algorithm complexity is talking about. So let's talk about something today. So an algorithm is, just like what you mentioned earlier, an algorithm is set of steps of operation to solve problem, performing calculation, data processing, and automated reasoning tasks. All algorithm is an efficient method that can be expressed with finite amount of time and space. Finite amount of time and space. An algorithm is the best way to represent the solution of a problem in a very simple and efficient way. If we have an algorithm for a specific problem, then we can implement it in any programming language. Just like we said earlier when we were discussing first time our class, your programming language, your algorithm is not actually dependent on any programming language. You can replicate a single solution, a single algorithm, you can replicate it in as many programming language you want. Then this is where we'll be talking about what we'll be talking about today, which is your algorithm design. Algorithm design. Please, this topic is very, very important. The reason I actually made a recap of what we did last week is so that we can actually flow. We actually flow from where we stopped last week to what we're actually doing now. So for your algorithm design, it is very, very important as a programmer. You understand what is required for every problem that you need to implement an algorithm for. Any problem as a programmer which you encounter, understand that the first thing you have to do is you have to analyze the problem. It is when you understand a problem, you analyze it, you tear it down into units, into sections, or into modules. That is where you'll be able to understand what is required of you. When we're talking about the characteristics of an algorithm, or things that you need to understand as an algorithm for a programmer, you understand that where there are characteristics which is being said that unambiguous, in the sense that for every iteration, for every operation that need to be carried out in an algorithm, it must be explicitly designed or explicitly communicated, in the sense that it should not be so jam-packed. For each operation, it should be well understood. There should be no assumptions. There should be no assumption. That means that everything that you need, you have totally understood the problem, then you now break it down into pieces. You break it down into pieces. Algorithm design. The important aspect of an algorithm design includes creating an efficient algorithm to solve a problem in an efficient way, using minimum time and space. Minimum time and space. To solve a problem, different approaches can be followed. We've said that repeatedly. Some of them can be efficient with respect to time consumption, whereas the other approach may be more efficient. However, one has to keep in mind that both time consumption and memory usage cannot be optimized simultaneously. Please have this at the back of your mind. You cannot maximize time and space simultaneously. You have to sacrifice one for the other. You have to sacrifice one for the other. If we require an algorithm to run in less time, we have to invest in more memory. If we require an algorithm to run in lesser memory, we need to have more time. So these are the two things. Just like we said earlier when we were talking about the complexity of an algorithm, talking about the time factor and the space factor. So you can't actually efficiently maximize two of them. You can't. At the same time, you have to sacrifice one for the other. You have to sacrifice one for the other. Okay? Please, let's take note of this. Then from there, we go to what is called problem development steps. Problem development steps. What is needed in this stage for you to understand is that just like there is a course called software development life cycle, it is very similar to this. Software development life cycle talks about the steps that are needed in creating a software. So in the same way for your algorithm, there are steps that are needed when you want to embark on development of an algorithm. The first thing which is needed here is the problem definition. The following steps are involved in solving computational problems. The first thing is problem definition. Problem definition is talking about understanding the problem which you've encountered, the problem which you are about to solve. You should understand it. You should actually pay attention to how the variables which are needed. Understand how understand how data should flow from each channel to the other channel. You should be able to draw a flow chart. You should be able to draw a flow chart of how the problems will flow, so that in a case you could use a flow chart or you could use a use case diagram, whichever one you want to use. Understand that operations, the problems are most of the times there are problems which are needed, which are you need to solve could be real life problem, whereby so many assumptions will have to be in place. But in the sense that in that situation, understand that every step, every operation need to be well understood. Need to be well understood. Take for instance, before when you begin to analyze the algorithm that is used that was used um, in the operation of your ATM machine, you understand that there are many functions or there are many modules for that. There are many modules because once you go to the first thing that is needed when you want to withdraw money with an ATM machine, understand that the first thing is your PIN number is being supplied, and once you supply your PIN number, at that stage there is a backup system whereby your PIN number is already being stored. The algorithm checkmates it, whatever you are supplying now with what is in at the back end. If it correlates, then you go to the next step. If it does not, then you still remain in that first operation. These are the way which you have to analyze your problem individually, one step at the other, one step at a time, one step at a time. You pay attention to every details that is needed. So that is for problem definition. Then the second one is the development of a model. Development of a model. Now you've understood your problem. Then you use your use case diagram or your flowchart now to bring out a model. Now you've not started implementing your algorithm. You implement a model. That is, you are from your problem analysis or from your problem definition, you are bringing out variables that will be needed, for the solution. So you are now you begin to bring out what is needed, the variables, how data will flow from one entity to the other entity. At each operation, what should happen? Then from there, you go to what is called a specification of an algorithm. Specification of algorithm is now telling you about the functions of which these variables will be performing. The variables which you have drawn out from your development models, the variables which you have drawn out, their operations. That is the specification of which each individual, of which each entity will be carrying out. Because you have to understand that each entity supposed to carry out one operation. You don't just give a single entity two operations to carry out. So please, we should take note of this. Then the next one here is design of an algorithm. Design of an algorithm. You are designing this algorithm now based on number one, your problem definition, your development of a model and specification of the algorithm. You don't need to develop something that is outside these three things which we've talked about. So everything which you are the algorithm now, which you are bringing into existence now, should be something that is giving a solution to your problem. The problem which you have well understood. Then you now develop a model for it. Then the specification of the algorithm is well understood. So for each iteration, for each variable, you understand what their function or their performance will be. Then now you go to the checking the correctness of an algorithm. Checking the correctness of an algorithm means now you begin to supply inputs to it. You begin to supply inputs. you know that you already know that this should be your determined output. If it does not give you your predetermined output, you know that something is wrong. You have to go back to your algorithm. You have to go back to begin to tear them down, to begin to know which is needed. This is very simple. This it's very simple, like when you are programming. Understand, when you are programming, you understand that there are things which you already perceive or already know that this should be your predetermined output. So when your program is not running, understand that perhaps something has gone wrong. So you have to go back to your code source, or you have to go back to your source code, and you begin to check each line after the other. The same thing with your algorithm. So when you understand that, when you see that the output which you desire is not coming forth, so you have to go back. Then you checkmate each and every one of them, every of the process or every of the operations which is supposed to be carried out. You check them one after the other. At the end of the day, your determined output should be you should get it, because based on the problem or your problem definition, an output should be the output of the problem, that means the solution of that problem should be satisfactorily met, should be satisfied. Then from there you go to the analysis of the algorithm. The analysis of the algorithm now is now telling you, based on everything which you have seen, based on everything which you have implemented, is there any way which you have to, is there anything which you have to do more to make it more efficient? You have to check. Remember when we were talking about algorithm analysis, we're talking about time and space. So understand that you have to sacrifice one for the other, be it time or space. You can't actually maximize both of them simultaneously. So understand this. In this place, you know that, okay, since due to the nature of this, I have to sacrifice time for space, or I have to sacrifice space for time. Analysis of an algorithm is talking about how efficient your algorithm should be. How efficient your algorithm should be. Then now the implementation of that algorithm. Implementation of the algorithm. Now the algorithm, based on everything which has been in place, you implement it. Implementation is talking about your programming. Your programming. Then now you go to your program testing. Program testing. Program testing is talking about now your program which you have used to implement an algorithm. Understand that there are different things. There are times for a specific kind of program, for a specific type of algorithm can actually be more efficient due to the smoothness or the robustness of a program. A type of an algorithm can actually be more efficient on one program. So it is now left for you to choose the best program that you can use to make this algorithm run very smooth. Then documentation. All along the way, all these things which you've actually put in place, there needs to be a documentation for them. There need to be a documentation for them. So these is what is being called, these are how algorithm is being designed. Please, we should take note of this. This is how algorithm is being designed. All these things along the way is what has a programmer, you need to understand. You need to understand each and every one of them. Understand each and every one of them along the way. It's needed at each point for you to do. At each point, what is needed: program development of a model, specification of an algorithm, design of an algorithm, of an algorithm, analysis of an algorithm, implementation of an algorithm, program testing, and documentation. These steps, understand them. Don't worry, I'm going to send the handout, the materials to everybody. Please understand it, because you might actually come. It might come to a time whereby you need to even refer back to them. Okay, from there we'll go to what is called the characteristics of an algorithm. We are actually talking about this again because we'll get to understand that there is a different thing apart from algorithm. There's something that is very similar to algorithm also, that is called piece of code. The reason for this is so that we understand that there is a difference between algorithm and piece of code. Okay. Okay, characteristics of algorithm. The first thing here is the main characteristics of an algorithm are as follows. Algorithm must have a unique name. This one is kind of different from what we did from the first thing which we did before. Algorithm must have a unique name. It must have a unique name. Depending on the situation, depending on the problem which you are about to solve. The algorithm, your naming convention of an algorithm should actually match the problem. For instance, you have an algorithm that is used for sorting, an algorithm for deletion, algorithm for input or deletion, algorithm to update. All these things are different kind of algorithm, and their naming convention should be peculiar to the problem which they are trying to solve. Algorithm should have explicitly designed set of inputs and outputs. Algorithm should have explicitly defined set of inputs and outputs. All the inputs, all your variables should be well explicit, should be simple. There should be no complexity among it. There should be no it should not be ambiguous. Everything should be simple. Break it down to the simplest format. Break it down to the simplest format. Breaking an algorithm every steps down to the simplest format does not warrant you to begin to impute unnecessary information there. No, it is different. Informations that are not needed should be taken away. Break everything down to its simplest format. The next thing here is algorithms are well ordered with unambiguous operation. Algorithms are well ordered with unambiguous operation. So every step along the way, every iteration or operation should be well inculcated. That is, after this step, move to step 3 or step 4. If this is met, if this condition is being met, it's just like saying, if this condition is being met, go to step 3. Perhaps if this step is not being met, go back to step 1 or jump to step 4. So these are the things which you have to understand. So let me take the case of your ATM also again. If the pin correlates, if whatever the pin that is being supplied, you input your ATM card and it pops up the page for you to impute your pin. It tells you what is being written behind it is, if the pin, whatever variable that is being supplied, if it correlates with what is at the server, then go to the next stage. So these are the things which you have to understand. In a situation whereby you want to change your PIN, understand that the old PIN need to be also supplied also. So you put in your ATM now, you put your PIN. After supplying your PIN, then you want to change the PIN because you feel that, okay, now at this stage I have to change my PIN. So you say it asks you now to actually supply your old PIN, even though you even supplied it in the first stage. So these are steps which you have to understand that for each step they should be well ordered. They should be well ordered. Then every step which are well ordered, they should not be ambiguous. That means everything should be clear. The operations should be clear. Then the next one is algorithm hot in a finite amount of time. Means algorithm should not run for infinity. Algorithm cannot run for infinity. After every process, after a process is completed, there should be the next. And understand that at the end of the day, your algorithm should have a place which it has to terminate. So these are the characteristics of an algorithm. I use this my time to break it down so that we understand that for every algorithm, these are what is required. Then from there, we want to talk about what is called PISO code. So PISO code gives a high-level description of an algorithm. PISO code gives a high description of an algorithm without the ambiguity associated with plain text, but also without the need to write the syntax of a particular programming language. We are going to continue here from next week because we'll reach time for questions. Time for questions, please. Please, time for questions. No, you want to. Okay. I will we'll come back to the questions. Please, I'll write us to the assignment which I will give for today is the assignment will be the first assignment will be what is a PISO code? What is a PISO code? PISO code is PISOCODE. What is a PISO code? PISO code is spelled as PSEDOCODE. What is a PISO code? The second question is differentiate between a PISO code and an algorithm. That will be the question for today. Please make sure you do them. The email to submit it still remains sharonchris29@gmail.com. 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 You still have my number in case of anything. Hello, I'm with you.
Hello, can you hear me?
I think I'm hearing some. Hello, hello. Yes, I'm hearing you. Ask your question.
Good evening. Good evening. Sorry, sir. Like the assignment you gave for the
Good
last
evening.
class. Good evening, Amalina. The assignment you gave for the last class. I don't understand it. I don't understand the last question you gave. Yeah.
Okay, were you around when we started?
I joined when you were explaining.
Were you online when we started this?
I joined when
Okay,
you were explaining.
So this very class. Okay, for this very class.
Was I asking for this very class?
Okay, the assignment is for. Yes, this very class.
I'm not. Yeah, I was with the class.
Hello,
I was going on with the class. Yeah, I was active. I'm
Okay,
talking about the last assignment you gave us. I was saying I joined when you were explaining the last assignment, so I didn't understand.
Okay. Okay, fine, no problem. For that previous assignment, if you actually joined when we started, that means talking about that I made mention of what is actually needed. For that previous assignment, what was actually needed was from you. The question was between you have variables. You have even numbers between 1 to 50. The even numbers between 1 to 50. You know what are even numbers? Even numbers are numbers that can divide itself without a remainder. Even numbers between 1 to 50, sum them up. After summing them up, then you divide it with me and you display the answer. That was actually what was needed. Are you there?
Yes, sir.
Did you understand it?
Yes, I understand what you said. Thank you, sir.
No. Okay, please, if in case you don't understand it, please send me a text message or call me directly. Yes, then I will explain more to you because we've exhausted our time.
Hello.
Okay, sir. Okay, sir.
Sir, please, hello, can we have your WhatsApp? Hello.
We've almost exhausted our time. Please send me a message on WhatsApp and we'll reply everybody.
Hello. The WhatsApp number, can you please send to us?
08133.
Your WhatsApp number, sir.
Yes, 08133. 08133 121 309. 081.
Okay, thank you, sir.
08133 121 309.
All right, sir. Thank you so much.
Yes, call me or send me text message on WhatsApp. I will definitely reply you.
Okay, sir. No problem.